So today I'm going to show you a very fast and easy way to balance combustion reactions. Note this is complete combustion. And if you do not know how to identify this particular reaction as a combustion reaction, then you might want to check out my video on the different types of chemical reactions, and it will help you classify these. So just a quick reminder, your generic formula for complete combustion is you have a hydrocarbon plus oxygen gas, and every single time in complete combustion, it's going to yield carbon dioxide and water. Every single time. It does not matter what order this is listed in. In these examples, I'm actually listing carbon dioxide first, and I'll show you why. So looking at our first example here, and to walk these two step by step. So we have heptane, which is, hept is 7, so C7H16 plus oxygen gas, oxygen is diatomic, and every single time it's going to produce carbon dioxide and water. So let's balance this very, very fast. So your first step is this. So you want to label your carbons on both your reactant and your product side. So I'm going to put a little 1 underneath my carbons on both sides. Okay. So you want to count your carbons on your reactant side, which is 7, and write that number as your coefficient on the product side. So 7. Done. Next, you want to label your hydrogens. So this is step 2, so I'm labeling a number 2 and a number 2 on both my reactant and product side. So then you want to count your number of hydrogens on the reactant side and divide by 2. Okay. So 16 divided by 2 is 8. And you want to write that number in front of the coefficients on your product side. The reason we're dividing by 2 is right there. Done. Third step is we want to balance our oxygens. So label your oxygens on your reactant and product side. So step 3, and notice oxygens occur twice on the product side. So after you label them, you want to count your oxygens on the product side only. So my oxygen number is, and don't forget to multiply your coefficient. 7 times 2 is 14. Okay. And then 8 times 1 is 8. So then that gives me 14 plus 8 is 22. Now, since this is an even number, 22 is an even number, what we want to do is we want to take that number and we want to divide by 2. This is why we're dividing by 2, which is 11. And we are done. And I'm going to quickly show you how this is balanced. So very quickly, carbons, hydrogens, oxygens, carbon, hydrogens, and oxygens. So we have 7 carbons, we have 16 hydrogens, and 11 times 2 is 22 oxygens. On this side, we have 7 carbons, we have 8 times 2 is 16 hydrogens and oxygens. We have 7 times 2, which is 14, plus 8 times 1 is 8, which is 22. Balanced. So that's our first example of when we have an even number of oxygens. So my next example is going to be an odd number of oxygens. So I want to show you how to solve for that. So my second example is with decane. So if we have, same situation here, we have our carbon and our hydrogens, our hydrocarbon here, and we have our oxygen gas, and our products are simply carbon dioxide and water. So let's follow the same steps that we did before. So first step is we want to label the number of carbons on both the reactant and product side. So step 1. So we want to count our carbons on our reactant side, which is 10, and we want to put that number 10 as our coefficient on the product side. Done. Next, let's label our hydrogens. So this is step 2. Step 2. we want to count our hydrogens on our reactant side and divide by 2. So 22 divided by 2 is 11, and we write that number as our coefficient on the product side. Final step, we want to label our oxygens, so label them 3. Notice again, oxygens occur twice here. So for step 3, we want to count our oxygens on our product side only. So oxygen number, multiply your coefficients. 10 times 2 is 20. 11 times 1 is 11. So we have 31 oxygens. Now, we know that that is an odd number. So when we have an odd number of oxygens, what we do is this. We take that number and we write it as our coefficient on the product side. We write 31, and then we double all other coefficients. So this 1 doubles to 2, this 10 is going to double to 20, and this 11 is going to double to 22. Very fast. And just to quickly show you that this is indeed balanced. So we have carbons, hydrogens, and oxygens. So our number of carbons on this side, 2 times 10 is 20. Our hydrogens, 2 times 22 is 44. And our oxygens, 31 times 2 is 62. On our product side here, 20 times an understood 1 is 20. 22 times 2 hydrogens is 44. And our oxygens, 20 times 2 is 40, plus 22 times 1, 22. 40 plus 22 is 62. So it's balanced. Okay. The last example that I want to show you today is one that has a oxygen attached to the hydrocarbon here. So I'm going to show you how to solve for this using pretty much the same methods with one additional step. So again, let's start off by labeling our carbons. So step 1, label your carbons. Step 1, count your number of carbons on the reactant side, 3, and write that as your coefficient on the product side, 3. Step 2, label your hydrogens. Step 2, count your number of hydrogens, just 8, and divide by 2. 8 divided by 2 is 4, and you write that number 4 as a coefficient on your product side. Lastly, we want to count and label our number of oxygen. So notice oxygen occurs twice on the reactant side. So step 3, step 3, step 3, and step 3. So we want to count your oxygens on your product side only. Multiply your coefficients. So 3 times 2 is 6. 4 times 1 for a total of 10 oxygens here. Now, note this. We have an oxygen on this side. We are not counting this. I'm only counting this one. So what we have to do is we have to subtract the oxygen number that is attached to this hydrocarbon, which is 1. So 10 minus 1 is equal to 9. 9 is an odd number. So what we have to do in this case is, remember, when it's odd, we write that number as our coefficient here, and then we have to double everything else. So this 1 is going to double to 2, this 3 is going to double to 6, and this 4 is going to double to 8. And we are completely balanced now. And again, I'm just going to run through and show you how this is balanced. So we have carbon, hydrogens, and oxygens. So carbons, 3 times 2 is 6. Hydrogens, 8 times 2 is 16. hydrogens. 8 times 2 is 16. And our oxygens, we have 2 times 1 is 2, plus 9 times 2 is 18, for a total of 20 oxygens on the reactant side. So carbon, hydrogens, and oxygens. Do the same thing here. So 6 times 1 is 6. Our hydrogens, we have 8 times 2 is 16. And our oxygens, we have 6 times 2 is 12, plus 8 times 1 is 8, and 12 plus 8 is 20. So we are indeed balanced. I hope that you find that this method is very fast and easy for you. Thank you for watching.
Thank you for watching. Make sure to check out my other chemistry and physics tutorials and to see my arts and crafts that were inspired by science.